Given the graph of a function y is equal to f of x as shown, how do you calculate the area of the region bounded by the curve y is equal to f of x, the ordinates x is equal to a and x is equal to b, and the x-axis? Actually, it's quite simple. Let's see how to do it. Begin by inscribing two rectangles under the curve within the limits x is equal to a and x is equal to b. These rectangles are taken in such a way that they cover the maximum area under the curve. Is the sum of the areas of these two rectangles the required area? No, it's not. This is because there is some area left uncovered which is above the rectangles and below the curve. Now, let's divide the region whose area is to be found into some more rectangles. Even now, the sum of the area of these rectangles is less than the area of the required region, as the shaded region is still left out. So to get rid of the region left out, we divide the region under the curve into an infinite number of rectangles, so that the curved line on the top of the small subdivisions appear to be a straight line. Observe that these four-sided figures resemble rectangles. So now, if we calculate the sum of all these rectangles, which are of negligible width, we get the required area. The width of each rectangle being negligible, we can assume that each has an infinitesimal area. Let the area of the first rectangle be dA1. Let the area of the second rectangle be dA2, and so on. And let the area of the last rectangle be dAn. The sum of the areas of these rectangles can be assumed to be approximately equal to the area of the required region. Therefore, the area under the curve between the limits is approximately equal to the sum of the areas of the rectangles. In mathematical notation, this can be represented as shown. Here, dA is the area of any rectangle, which is equal to the width of the rectangle multiplied by its height. The integration is performed from the ordinate x is equal to a to x is equal to b. The height y is nothing but the value of the curve at point y. Therefore, y is equal to f of x. Let's substitute this in the integrand. With this method, we can calculate the area under any curve. Now, suppose we wish to find the area under the curve x is equal to g of y. In this case, the limits of the integral are determined between the lines y is equal to c and y is equal to d. So the area under the curve is given by integral of g of y dy from c to d. Often we come across situations where the area of the region that we must have to find lies under the x-axis. For example, let's take the sine curve between 0 and 2 pi. To find the area of the region between the curve and the x-axis, we split the figure into two parts, as shown here. Here, the value of the function is positive above the x-axis and negative below the x-axis. Let the area above the x-axis be denoted by A1, and the area below the x-axis be denoted by A2. So the total area enclosed by the curve with the x-axis is A1 plus mod A2 as shown. Now, A1 is equal to the integral of sin x dx from 0 to pi, and A2 is equal to the integral of sin x dx from pi to 2 pi. The area can be calculated as shown. This gives the area between the curve and the x-axis equal to 4 square units.